Hey guys, you're watching Concept, and in this tutorial we're gonna create this remainder. Actually, we're gonna spawn this remainder, and we will create it by using that already known scale of remainder and some other things. So let's get started. So in the last part we got something like this. This is intersection, and also we got like we said before, we got that remainder scale. So what's gonna be remainder before we got this intersection? But the problem was that we only got how what is the scale of this remainder, but we didn't get the position. So basically, how we're gonna find position of this remainder? The position of this remainder will actually be position of this intersection plus half size of this original previous tile. So basically, I know that this maybe sounds like something weird, but actually if we duplicate this and use the half size of previous tile, you will see that their center is actually the center of this is on the between those centers is half the size of the previous tile. So even if you scale it, for example this size, now watch this and this circle. So this center will be actually be, you can see, the half size of the previous tile. So in that case, what we're gonna do is to find the position for this remainder. It will be the position of current tile, which is actually intersection now, plus a half size of previous tile. I know that it sounds weird, but that's the way it is. Now we should go back to our stack spawner, and we will create a new function which will be called spawn remainder left. Okay, so it will be called spawn because we will spawn from this. We will calculate and spawn from this, and we will need 3 inputs. So the first input will actually be tile. It will be the same, so current tile, previous tile, and this one will be actually, this will be fed by if you remember, we got that scale. Where to find it? Yeah, this was the scale from that remainder. So we will say remainder scale x. Okay. Now before we do anything, I just want to make tile. We'll make duplicate from tile, and we will call it tile remainder. Okay, so tile remainder, we will just say that it simulates physics, and that's about it for now. So we will save it back to spawn. So we will say spawn actor from class tile underscore remainder. Okay, so now we have to put its transformation, make transform. Now we have location and scale. Let's first do the scale. So we will say make vector. We know that we already get that remainder scale, so we'll fit it with x. The current tile will actually give us, so just to see how we did here, it was current and previous. Okay, so current previous. Okay, so current tile get actor location, not location, get actor scale break. So y and z will be the same. Okay, before we find that location, we need to do one thing. That is to go back to our intersection left and to say return. Okay, and we will return So our return will be float with the remainder left, remainder scale x. Okay, we said that we got scale from this subtraction, current tile from previous tile, divided by 100. That is all alright. But you remember that we put absolute so we don't have plus or minus. But we will need that plus or minus for remainder, because if we got that plus as a sign, it's on the left side. So if we got minus, it's on the right side. So if, for example, we know that in that case it's on the right side, this will be on the right side and this will be on the left side. Not right and left spawner, but right and left side of according to previous style. So we know if we're gonna spawn there or there. You will see why we need this. So we will not send absolute, but we will pass without absolute. Okay, I'll fix later this. So we'll go back to our event graph and we will say where's our spawn remainder left. Okay, so let's, and we will connect these and also connect these. Okay, let's go back. So in that case we send it with plus or minus. For the scale we will also need apps, but for our location that plus and minus is actually very valuable to us, because we can say sign. So this will give us either that plus or minus b. Why is that important? Because if we say previous style, we want to get that half of previous style. We can get that half by scale or by its box extent. So we can bounds, get actor bounds, and we can get its box extent. Box extent will always be half from center to its end. So box extent, we can say not origin but box extent, break, and we can say break it, and multiply it with that sign. Why multiply? Because this will actually always be positive. It will always give us positive, but we need to know if it is a negative, it means that it should spawn here. If it is a positive, it means that it should spawn here. So that's why we needed that plus or minus when we do the subtraction of current and previous, because with that we get this sign which tells us, okay, we need to get a half in plus or minus, either that be on left side or right side to spawn that remainder. It's a little bit difficult, but it isn't so much. So we will say current tile get position location, okay, break, as we talked before in drawing. So box extent, that is that half plus position of current tile, so we will say plus, and with sign we know on which side, okay, plus, and we get that location finally. So break, not break, make vector, and we got this. Y should be a location of a current tile. Can we find it? Yeah. So that is Y, that is Z. And yeah, that's pretty much it. I think this should work just as fine. So let's find out. If we go and hit play. Oh yeah, you see that it's breaking and it's all working fine. Now we have to do that for the right side of a spawner, and we will fix that flying away, so it won't be that much of a bounce. Okay, but before we get this duplicate for our right side, we need to set one condition. For example, if we see an event graph, we go to our spawn remainder. But problem is, if we don't have anything to spawn, for example, let's say that our position, if you remember, less than tolerance, and there it goes right here, it doesn't need any spawning. In that case, we will also have to return one thing, and that is B can spawn. So if this is true, then say can spawn. Make literal bool, so can spawn equals to true. But if this happens, then we need return node. Okay, in that case, can spawn, it cannot spawn. So we'll say false, remainder scale will be 0, we don't even need it. So that means if it goes like this, if it is a place on the same place, you do not have to spawn anything. Okay, let's go back to our remainder, and we say we need inputs. B can spawn question mark. So we will say a branch. So if it can spawn, then go and spawn it. If it cannot spawn, then just, if it is false, then we will say return. Just return, and that's all. Okay, we can fix this a bit. But yeah, you can do it yourself also. So try not to have so messy these nodes. Yeah, that's pretty much it. Okay, so it won't spawn anything, it will just return if we set it on the right place. And yeah, this can actually go like this if you don't want to mess it too much. Okay, now we will create the same for a right side remainder. So we'll say duplicate, call it right, and we can say remainder scale Y. Okay, so in that case we will need what we're gonna need. This will be Y, this will be X, this will be Y, this will be Y, this will be X, yeah. So we fixed everything, I think. Yeah, so compile save. And we need to get something like this for our right. So we need to get these, and in our right just to see if everything's working fine. Yeah, remainder scale, but it will be called Y. Okay, and we'll be needing this, and fix it for yourself, because I think that you don't want it to be this messy. And that's about it. Now let's try it. Oh, could not find. Okay, so we need to replace this with the new one. Okay, and we will say this set will be here, and our spawn right will be here. This will be here. This will be here. Oh yeah, we didn't connect can spawn. So can spawn connected. Previous tile, current tile, connect those. So previous, current. Okay, now we should try it out and see what happens. So we got some problems here. Oh yeah, I made mistakes. So if we go back to our stack spawner, I did not connect this. So check twice what you did if everything's connected. And on right, I made one mistake. When we change things, this should be fed for Y, X will be here. I fed this with X, so I also got some weird results. So if we play now, we will see. Okay, everything is looking great. Yeah. Now let's fix that bounciness. For that bounciness, we will have to create. So we will create physics material. Where is physics material? We will call it tile matte. And we need to set our density to 50 at least, and we will say that this has that physics material. Where is that? Okay, tile. And also we will say friction 0.5, although it won't affect much. As for collision, this also affects physics. So for example, if we have a simple collision which is, for example, remove all collision, and we say just box collision, this will actually affect bouncing. So we will have to say at least this 18 dop simplified. Okay, let's see if we fix some things. Yeah, it's a little bit better, but you can always play with physics. And I got some really weird things going on, like this, you can see. That happens, as I told you, with collision. It has to do with collision. We can try this one. So you should try, I don't know, any kind of collision. You can even make your custom collision. Yeah, this fixed it. So if you have problems with physics, it's probably because of collision. And one more thing we want to stop is that, for example, when we are not on this previous tile, so for example, when we are here, okay, that we cannot put, actually we cannot do intersections or any kind of spawning, because if we do, you can see something like this will actually appear. In that case, we will have to say, first of all, go to our tile, static mesh, and we will have to find collision. We will say custom collision. So we will say this is world dynamic, and we will say overlap world dynamic, so overlap itself. Okay, and this remainder will actually be a block call, we will say. So it will block call. Okay. So we will go back to our spawner, and we will say, where is our event graph? So we know that this actually calculates and spawns and so on and so on. In that case, we need to say put one more branch. So in that case, we have to say branch. So current tile is overlapping. If it is overlapping previous tile, then in that case you can start spawning. Okay, let's see. Okay, it's all working fine, so it's not spawned, it's just stuck. We will say if so false condition will actually be we'll create custom event and game. So current tile get, we will say something like simulate physics, set simulate physics, so it will fall down. Okay, but one more thing, yeah, this should be before moving. Okay, so if it's true, go here. If it isn't, then end game. Okay, so let's try out. Okay, it just falls down, and we will later say to write down whatever we want to write down, so game over or whatever. So yeah, that's pretty much it. In the next tutorial we will talk about colors, how we can change colors, how we can change color of a tile, and we will make some algorithms. So yeah, stick with concept, and we'll see in the next tutorial. Bye.